Okay, we're really briefly going to define collisions. Collisions are an interaction between one or two or more objects, between two or more objects. And there are two types of collisions that we want to identify. The first type of collision is what we call an inelastic collision. This happens when two objects stick together, two or more objects stick together. So objects interact, and at the end of that interaction, they are stuck together. You can imagine a collision between three globs of clay being thrown at one another. They're sticky, and so they stick together. And they become one unit. Now, what's sort of special about one unit is when we look at how to analyze collisions, that we notice two things. One, their mass adds together. And two, their velocities become the same. So a glob of clay might have an initial velocity and another glob of clay might have an initial velocity that are different. When they collide and stick together and move off together as a collective glob, their masses add together and their velocities become the same velocity. The final velocity after that interaction, that collision of glob 1, is the same as the final velocity of glob 2. So an inelastic collision occurs when objects interact. And at the end of that interaction, the objects stick together. They're stuck together. The second type of collision that we need to discuss is what we call an elastic collision. And as you might imagine, that's going to be the opposite of sticking together. So when objects interact, they bounce off one another. Now, in this case, everything stays independent. The object 1 bouncing like a billiard ball, hitting object 2, their final velocities and their initial velocities are different. Their masses don't combine. Everything stays independent. Now, there is what we call a perfectly elastic collision and a perfectly inelastic collision. So we're going to worry about that if we deal with energy and when we talk about energy of collisions. Right now, we are going to look at collisions in terms of momentum and use momentum and the conservation of momentum to solve problems with collisions. So in both of these situations, momentum is conserved. And we can use that idea to look at problems with collisions. All right, good job.